Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today is the seventh lecture of the dynamic programming playlist, and this problem is quite interesting because you're gonna learn a lot of stuff. Yes, trust me, when this video ends, you'll be like, wow, dynamic programming is so super cool. So the question goes by the name Ninja's training. So Ninja is planning this n days long training schedule. Each day he can perform any one of these three activities. So there are three activities that the ninja can perform: running, fighting practice, or learning new moves. I forget about these stuffs. Each activity has some merit points on each day. So there are three activities. If you perform any activity on a given day, you get some points. Now, as ninja has to improve all his skills, he can't do the same activity in two consecutive days. That means if on the first day he has done running, on the second day he again cannot run. So two activities cannot be done on consecutive days. Something similar to the lecture 5 where it was stated that you cannot pick up consecutive numbers. But over here you have to perform something, like you cannot skip the next day, you have to perform something. This is where the question is slightly different. Okay, so can you help ninja find out the maximum merit points that the ninja can earn if he has n days? Now you're given a 2D array of size n cross 3. It's a slightly different one, n cross 3. Okay, so basically there will be 3 columns and n rows with the points corresponding to each day and activity. Your task is to calculate the maximum number of merit points that ninja can earn. So let me just explain you what does this mean. So basically it means these are the 3 columns. So this is running, this is some activity, second, like I can say first activity, second activity, third activity. This is what I can easily say. And this is day 1 and this is day 2 points. If there was someone else, it would have been day 3. It is as simple as it can get. This is how it looks. So I can say this is definitely a day 1 or 0, whatever you can call it. This is a day 1. Okay, so you have to perform on 2 given days. So greedy again, the first step that always comes to our brain is greedy. So first of all, if I perform on the 0th day, my greedy nature will say, on the 0th day, I have 3 tasks that I can perform. Which one gives me the maximum? And the answer that comes up is 50. 50 gives me the maximum. So what I'll do is I'll take 50 and perform it, right? So that is greedy. Next, on the first day, I know since I performed 50, I cannot perform 100. That is what the question states. If you have performed a certain task, like this was the task, what is like fighting practice something. If this task has been performed, on the next day you cannot perform that. Yeah, on the next day you can do, but on the exact next day you cannot do. On consecutive days you cannot perform 2 tasks. So this cannot be performed. So either of 5 or either of 11. So the maximum is 11 that you can take. So 11. Now if I sum this up, you will get 61. At max you can collect 61 merit points, but is this the maximum? Now the answer to that is no, this is not the maximum. You did greedily, but you will fail. Why? Because since you did greedily, you took 50, you missed out on something which was much bigger in the next step. So ideally better would have been if you'd have taken 10, correct, and then you would have taken 100. So if you'd have taken 10 on the 0th day, like you have performed this task, then you would have performed this task, thereby the total would have been 110, which is indeed the maximum merit points that you can earn. That is what the question states. So we observed that greedy fails, and whenever greedy fails, you know what you need to do. First thing comes, try all possible ways. Yes, we're gonna try all possible ways. That's definitely the first thing that comes to my mind. And whenever I say try all possible ways, the first thing that comes to my mind is, let's apply recursion and try to do every possible stuff that I can do. Right now, if you remember, in order to write recurrence, I've told you 3 steps. What were the 3 steps? Step number 1, express every possible problem in terms of index. Second, do stuffs on that index. Very, very important. Do stuffs on that index. Third, according to the question, like over here the question states find the maximum merit point, so you have to find the max, so if you follow these three steps, you can definitely write any of the recurrence relationships, correct? Now if I ask you in this particular question, uh, can I say i can I can definitely do an index, because we have day 0, we can treat that as an index. We have day 1, we can treat that as an index. So the day can be treated as an index because I have to decide on a given day what I'm trying to do. So I have definitely decided what is going to be my index. So I can say, okay, fine, hey listen striver, we have decided that the day is going to be my index. So that's the first thing, index is day, like I'm naming the variable as day. But yeah, that's what overall. So we have decided whatever we are going to do is going to be on the day. On the 0th day, we're going to do something. On the first day, we're going to do something. On the second day, we are going to do something. But whatever we do will be on the index. So first step is done. We have decided the index. Okay. Now before thinking of any other logic, because I don't want you to cram the code. Before deciding anything, let's understand do stuffs. Okay, let's understand do stuffs. So generically, we will be doing recursion, which is definitely top down, and I generally tend to write it from nth minus 1th index to the 0th index. That is how I do it. You can do it the opposite way, where you take it from 0th index to the n minus 1th index. That is absolutely okay. So can I say, let's assume there are multiple days. Let's assume there are multiple days, okay? And your recursion is somewhere over here. And there are three activities on these days: activity 1, activity 2, activity 3. Now, when your recursion is over here and you have already performed this, in order to select a task over here, in order to select a task on this particular day, ask yourself what do you require. Ask yourself what do you require. You'll be like, striver, in order to perform any of the tasks, like either I can perform this, the task 1, or the task 2, or the task 3, there is something that I require. And what is that something? I need to know what was the last task performed. Like if you're going in this direction, someone has to tell you what did you perform here. Because if someone doesn't tells you what did you perform here, how can you maintain the question, how can you solve the question of not performing two similar tasks on two consecutive days? Because the question clearly states you cannot perform two similar tasks on two consecutive days, right? So thereby, always remember, according to the condition, I repeat, according to the condition, along with the index, you can add a parameter in the recurrence. Because over here, in order to decide what stuff I'll do on an index, I need to know what I did on the previous index. I repeat, I need to know what I did on the previous index. Because if someone comes and tells me that, hey, Striver, previous day I did the task 3, then over here in this I cannot perform the task 3. So someone has to tell me on the last day, what did you do? Yes, what did you do? Because if you don't tell me what did you do, how will I do? Got it? So what I'll do is I'll have the next parameter, which is last. This is how you solve. Go step by step. You solved index. Then you decided to do a stuff. But then you realized, oh, in order to do a stuff on an index, I need to know what task was done on the last day. Thereby, you introduced another variable as last, where you'll say last. That means this task was done on the last day. Got it? That's how you think. That's how you think of recurrence. So we have assigned, like we have done this first step. First step is done of recurrence relationships, which is identifying along with index if we need something else. So we identified along with index we need, sorry, rather the last day, the last task, whatever you did. So let's keep it quite simple, because we will be having zero based indexing arrays. So let's keep it something like task. Let's keep the numbers very straightforward. Can we keep something like assume if I'm passing last as 0 means task 1 was done, or task 0, like the first task was done. If I'm passing 1, the task 1 was done. If I'm passing 2, that means a task 2 was done. Remember all zero based indexing, I'm now assuming, just to be familiar with the arrays. And if I'm passing 3, that means no task was done. No task was done. Again, when will the case of 3 arise? You're very smart. You're very smart, isn't it? When will the case of 3 arrive? Obviously, when you start from the last day, which is n minus 1 a day. Because when you start on the last day, what options do you have? You have an option of performing this task or this task or this task. Any task you can perform, and thereby you go across all the possible paths, correct? So that's how you decide. So I can say initially the call will be made for f of n minus 1 comma 3, which states, what does this recurrence means? Give me the maximum merit points. Yes, give me the maximum merit points that you can earn on the array that starts from 0, ends at n minus 1, and before n minus 1 you performed 3, means no task were performed. Got it? So if someone writes f of 2 comma 1, it means give me the max merit points, give me the max merit points that you can get if you perform the task, like if you perform the task from 0 to the second index. 0 to the second index, what maximum you can get in this particular section of the array, given that you performed task 1 right at the third index. This is what f will be signifying. I hope that makes sense. Okay, now let's go on and write the recurrence. So can I say the recurrence will be quite simple? As usual, if I'm starting from n minus 1, where will it go? N minus 1, n minus 2, n minus 3, it'll go until 0. And 0 will be the kind of stopping point for you, the base case. Very straightforward. Whenever you're solving problems on index, 0 is bound to be a base case. So I can be like, okay, Striver, we have realized that 0 is going to be my base case. Fine, 0 is going to be my base case. Now, can I say if I have reached the 0th index, or probably this push, this guy, there will be 3 tasks over here, right? That there will be 3 tasks, and out of these 3 tasks, you will have to perform the largest one, which is not equivalent to whatever you have performed here. Which is not equivalent to whatever you have performed here. Make sense? So, what I can say is, okay, Striver, let's do one thing. We know there are 3 tasks, and you know that this is the last guy, right? So, Striver, do one thing. Just run a for loop from I equal to 0 to task number 2. And if this I is not equal to the last task, probably you can keep a max equal to 0. Can you just give me the max of maxi, probably you can keep this as maxi comma whatever task, like assume whatever task you are having, task of I on the 0th index, or rather let's write it properly, task of on the 0th day, task I, whatever maximum you're getting. Can I surely return this? Can I say this is my base case? Think properly. Makes sense, because you were having task 0 1 2, correct? You said something was performed on the last day. So bearing that, apart from that, consider all the other tasks and take the maximum among them and return. Makes sense? Because in the last portion, you just, if this was performed, you don't take this, and you take this and this and the maximum of that. Kind of makes sense, right? So we have figured out the base case. Now if you have figured out the base case, I think you would have also figured out what will you be doing on that given day. You'll be like, Striver, the best thing that I can do is I can try out performing the task, performing every task apart from the last task that I performed. Again, makes sense. So what I'll say is, okay, if you perform something on the last, I'll not perform it. But apart from that, I'll try out all the possible ways. Okay, kind of makes sense. So what I'll do is, I'll say it's the same thing again. I'll keep maximum as 0. And I'll similarly run a loop from I equal to 0 till 2. And I will say if I is not equal to last, that means if you have not performed this task on the last day, then you can perform this task. Now, I'll just erase this because you've understood this quite clearly now. Now, if you're performing a task, can you tell me how much points will you earn if you're performing a task I? That's very simple. On that given day, if you perform the task I, this is the number of points you will earn, correct? And if you're performing this task, you're earning this much points for this portion of the array, you have to find the answer. But that is something which recursion will do for you, right? So you'll be like, okay, let's go to the previous day. That's a very, very important stuff. Whenever you go to the previous day, whenever you're going to the previous day and asking the function to find this answer, the function to find this answer, you have to tell that guy that, hey, I performed the task I on the last day. I performed the task I on the last day. So please tell him that I have performed this particular task. If you performed the second task, tell him you performed the second task. If you performed the first task, tell him you performed the first task. So that whenever this guy is whenever this guy is encountered, he doesn't again performs the first task. So you will be like, go to the previous day and tell him that on this particular day, like right before this, you performed the I task, so do not perform that. So can I say the current plus the reduced array is what the total merit points will be, right? Thereby, if I am doing it on all the tasks, if I'm doing it on all the tasks, can I say the maximum of all the task, the maximum of all the task will be indeed my answer? That makes sense. So I will say let's return maximum because that is the maximum merit points that I can definitely make. So if I just keep the recurrence together, this is how it looks. Quite straightforward, quite simple. Just make sure you perform every task apart from the task that was performed in the other day. So if whenever you start off with f of n minus 1, whenever you start off with f of n minus 1, you can pass on 3, right? So whenever you are at the last index, which is n minus 1, you try out this task, then you try out this task, then you try out this task, because this will be 3 and the task numbers are from 0 to 2 and the task numbers are from 0 to 2. So you can try out all the tasks when you start off with, right? So this is what the recurrence will look something like. So in order to understand if there are overlapping subproblems or not, or how does the recursion work, just in case you're not comfortable with recursion, let's quickly draw the recursion tree by taking n equal to 4, where this is day 0, this is day 1, this is day 2, and this is day 3. Okay, and the task 0 is like this, the task 0, task 1, and task 2. That is what the points you'll get if you perform them on days 0s and 1s. So ideally, what you did was you started from the bottom, like the last row, which is the third row, and you said 3. What does 3 signified? If you remember well, 3 signified that none of the tasks have been performed in the previous day, because this is the last day where you're starting off. So before this there was no days, so none of the tasks have been performed. So what are the options that you have if you're over here? Logically, you can perform either task 0 or task 1 or task 2. That's on you. You can perform any one of them, right? So what you'll do is you will be like, okay, let's perform the task 0, let's perform the task 1, let's perform the task 2. You try to perform every possible task. So you'll be like, okay, let's go to f of 2, and since you performed the task 0, tell them that you have performed the task 0. Go to f of 2, tell them you performed the task 1. Go to f of 2 and tell them you performed the task 2. Why do you do this? If you're over here and if you're saying you're performing the task 0, so whenever you go to the next day, like the next day, you don't want to perform 10. Thereby you told him, hey, take 0, do not perform 0. So he will go and perform only T1 and T2, which is task 1 and task 2. Got it? So that's how it will work. Now, if I carefully observe, we are at f of 20, and whenever there are three recursion calls, which one tends to happen first? This one, then this one, then this one. Let's perform f of 20 at first. So if you're at f of 20, that means over here, 0 means you cannot perform this. Thereby, you have two options, either this or either this. So you can be like, I can perform task 1 or I can perform task 2. You don't have any other options, or you don't have. So you'll be like, okay, if I'm performing task 1 on day 2, I'll go to day 1 and I will be like taking task 1 because I'll have to tell day 1 that I have performed task 1 in the previous day. Similarly, I have to go to 1 and I'll tell him that task 2, please carry task 2. Task 2 has been performed previously. Okay, makes sense. Again, this recursion will happen first and then this. So let's do f of 1 1. So when you are at f of 1 1, which means you are at here, and you're saying 1 has been performed. Thereby, you cannot perform task 1. So you can perform task 0 and task 2. Perform it. So you can perform task 0 and task 2. So if I perform task 0, I'll be like, I will go to 0 with task 0. I'll go to 0 with task 2. This is only what I can do. Okay, makes sense again. Now, a very, very interesting question to you. So, where were you? You're like f of 1 1 and you called something like you performed the task 0. So, if you perform the task 0, what will be the points that you will add on f of 1 1? You're performing the task 0. So, on f of task 0, 3. 3 is what you'll add if you perform task 0. So, 3 plus, you're calling this f of 0 comma 0. Remember this. So whenever this f of 0 comma 0 goes, it's a base case. If you remember the recurrence, it's a base case. Let's go back to the recurrence. It's a base case. Whenever the day comes to 0, it's a base case. So in the base case, what did you do? Let's come back. You know this, that 0 has been performed previously. So either of this or either of this. And you don't have anywhere else to go. So if this is the only day remaining, then you don't have to think of the future. So the maximum of that is 3. Thereby, this guy tends to return a 3. So this element comes out to be 3. Got it? Similarly, there will be this call which will be task 2. So if you perform task 2, which is 6, so it'll be like 6 plus f of 0 comma 2. So if you perform this task, you can either take 2 or you can either take 1 on this guy. Thereby, this returns 2. So you will return 2. So this will be 2. Now 3 plus 3 is 6. 6 plus 2 is 8. Which one will you take? You'll be like, let's take 8. Let's take 8. Again, makes pretty much sense. So I'll take 8. So I'll just take 8. Perfect. F of 1 1 is 8. Now we have f of 1 2. So definitely f of 1 1 is returning 8. So let's come back to the next solution, which is you're at f of 1 2 rather. So you're at f of 1 2. So whenever you're at f of 1 2, what will happen? You'll be like, let's call f of 0. Let's perform task 0. Let's call f of 0. Let's perform task 1. That's what you'll do. So again, same thing will happen. If you perform task 0, you will get 3 plus, and f of 0 0 will return 3. And if you perform f of 0 1, that's task 1, you will get task 1 for 4. So 4 plus f of 0 1 will be what? If you perform 0 1, that means you're coming here and you're saying you cannot perform this. So either of 3 or 2. 3 you'll get, right? So either 7 or 6. Thereby this gives you 6. Perfect. So you're getting 6. Let's now try to write it again. Now you're at here. So whenever you're at f of 2 0, it states, okay, I cannot perform task 0. Whenever you are at this guy, remember this. It is saying that you are over here, you cannot perform task 0. So either you can do this, which is task 1, gives you 1 point. So 1 plus, you called f of 1 1 because you performed the task 1. Or you can be like, let's perform 6. So it's like 6 plus f of 1 comma 2. So either you perform the task 1 or task 2 because task 0 was there, right? So 1 plus f of 1 1. What is f of 1 1? 8. What is f of 1 2? 6. So 9 and 12. Which one is maximum? 12. So you return 12. Got it? Now you'll start seeing overlapping subproblems. I hope you've got the basic how's the recursion working. So the first, I'll just show you one more. So over here, if you are doing the task 1, you'll be like task 0 and task 2. So f of 1 comma 0 and f of 1 comma 2. So if you carefully see, do we still see an overlapping? Yeah, this is the first overlapping subproblems that you'll see. So you saw an overlapping subproblems. So if the value of n is larger, you'll tend to see a lot more overlapping subproblems. Like over here, if you go t0 and t1, it will be like f of 1 comma 0. So again, overlapping subproblems over here. Kind of, yeah. So you will, the more you enlarge the tree, you will see overlapping subproblems, and this is how they will solve each other. And after that, you can easily get the answer. So we have again concluded that there are overlapping subproblems, and if there are overlapping subproblems, what do you need to do? You need to do one thing. What is that? Memorization. Yeah. And what is the easy step? You go back and say, okay, hey function, what are your changing parameters or what are your states? I see there are two states. One is index, the other is day. Oh, sorry, last. One is index or day, and the other is last. There are two parameters for which you have to give an answer. Like you are being said f of n minus 1 3, stating give me the entire array's maximum earning point, given that the task 3 has been done. So two guys dependent. So there was the first guy day, and there's the next guy last. How much is the value day? It can be like 0, it can be like 1, it can be like 2 till n minus 1. So there are n different values that day can have. What is the possible value of last if I ask you on a very simple term? Be like strival last can be 0, 1, 2, 3, nothing more than that. So four different values, which are 0, 1, 2, task 0, task 1, task 2, and 3, which states that all of these tasks have been performed. None of these tasks have been performed. So there are n 4. For every n state, there can be 4 different possibles. Thereby, you'll require an n cross 4 dp size array. Remember this, thereby you'll require an n4 initialized with minus 1. N4 initialized with minus 1. And was the first step? Definitely. Over here, you tend to write dp of index last equal to maxi. And over here, just one line, if dp of index last not equal to minus 1, return dp of index last. 2d dp done. If I reiterate, always the first parameter will be index. Next, depending on what stuff you are doing, in order to preserve the condition, you might require some more. And that's when the second parameter is introduced. If you require some more, remember these three tricks. You can write any recurrence in the world. So let's try to code this up. What we are given is the n and the points. So I'll try to write the recurrence at first. So the first thing was day, and then the int, and then the vector again, and int, and points. Now I know one thing for sure. If the day is the 0th day, then I need to figure out the maximum among them apart from the whatever was done on the last day. So really I can keep it as maximum 0, and I can say I can go across to all the task, or rather name it as task, or task equal to 0. I can go across to task, and there will be 3 tasks. So task plus plus, and we can say maxi. Okay, we just need to make sure this task is not equal to the task done on the last rather. So thereby this will be maximum equal to max of what maxi comma points on the day 0, and definitely on the task. So on the day 0, whatever task you're doing, so just make sure you take it off and you return the maximum. Perfect. And if that's not the case, I will be like, okay, maximum 0. If it's any other day, I will perform again the similar thing. Probably I'll be performing all the tasks again. How many tasks are there? Tasks will be this. Okay, by the way, 3. So I can be like task plus plus. Now what I can do is, if this task was not done on the last day. Let's do this task. But if I do this task, how many points will I generate? The points that I'll generate will be points on this day, this task, if I perform, plus I'll have to go to the -1 day to solve the smaller sub problem, and I'll have to tell him that, hey, listen, this is the task that I did on the current day. I have to pass on the points so that he gives me the answer. Once he gives me the answer, whatever he gives out of these, I'll take whatever is the maximum. So I'll take the maximum, and once I have the maximum, I can definitely return this one. It makes sense. I think this is looking quite good. So now I can return the function n-1. Initially start off with 3, and we can definitely pass on the points. It should be fine. So I'll just give it a run. So as you can see, there is time limit exceeded. So let's memorize it. So that's the way you can create DP variables. DP, and then you can give the first size, which is n. Then you can declare the second one, which is vector of int, uh, 4 size and a -1. That's how you declare a 2D's array, 2D DP array of n crossed 4 in vector. Why vector? Because I generally prefer vectors. It's very easier to pass in reference. That's the only reason. Java people can probably do arrays, not a big stuff. By the way, for Java people, you'll find the code links in the description. Okay. So DP is done, and yeah, you're calling F over here, so you can just pass on the DP over here. Right over here, you can say DP of probably day, and then there's something that's last, so you can just give it like this, and right before returning, just make sure you check it across. If DP of day last, this sub problem has been previously solved. If this sub problem has been previously solved, what you can do is DP of day, and you can say last. Can you please return that? And now let's code this up. It gives me a correct answer. Now let's quickly submit this. As you see, I was solving this before this class, and yeah, it runs. So we used recursion plus memorization in order to solve this particular problem. Now it's time to check out the next possible stuff, which is tabulation, just in order to reduce the stack space. So what's the next step? The next step is tabulation, because the recursion, as we saw, we were using something like the time complexity of memorization will be n crossed, because see, there are n cross 4 steps. Understand how many different states we can have? That's n cross 4, right? Like, not in all cases we'll have 4 states, but yeah, let's assume for the worst case it's n cross 4 states that we can have. If you carefully observe, for every state we were actually running a for loop of size 2, like for every state, or size 3 rather. So for every state you're running a for loop of size 3, so I can say it's n crossed 12 is the time complexity, and space complexity of b go off. The recursion stack space will be n, because at max you'll go for n days, but the space complexity will be n crossed 4. So this will be the recursion plus memoization time complexity, and this is an extra. Yes, this is an extra that you have to omit, and this you cannot reduce. So how can we first omit this recursion stack space? So we will be doing something as definite, which is tabulation. What did I tell you? What's the first rule of tabulation? Declare the similar size. Yes, declare the similar size DP array. That's the first thing that you will do. Kindly declare the similar size DP array. Next, whatever base case you have written on index 0, right? You have written on index 0. Now, whenever you're doing 2Ds, because these are 2D DPs, right? Whenever you're doing something as 2D DP, what should you keep generically in your brain? What can be D whenever you come across here? Try to think in this perspective of base cases, okay? So that's the trick. You'll be like, Striver, over here, index, if it is 0, either last can be 0, or it can be 1, or it can be 2. So I can say there are base cases like 0 comma 0, 0 comma 1, 0 comma 2. In all of these recursion calls, do you agree? In all of these recursion calls, or 0 comma 3 rather, like in all of these recursion calls, Do you agree that this base case, yes, this particular base case will be executed? You agree, right? Because if index is 0, no matter what is the value of last, they will be executed. Now let's analyze. What if it is 0? If it is 0, then you end up taking the maximum of task 1 and task 2 if it is 0. If it is 1, you end up taking maximum of task 0 and task 2. If it is 2, you end up taking the maximum of task 0 and task 1. If it is 3, which might be the case if there is a single day, then you might directly call 0 3. You will end up taking task 0, task all these guys maximum. So can I say the first form of tabulation will be nothing but I can simply write that as dp of 0 0 will be max of, so max of array of the 0 on the 0 day, task 1 or task 2, right? Similarly, the dp of 0 1 will be max of array of task 0 and array of day 0 task 2. Similarly, dp of 0 2 will be max of array of 0 0 array of 0 task 1. Similarly, dp of 0 3, like I'm just writing it like this, you could have used the similar for loop to write it, like, anyways, while writing the code we will do that. This was done in order to explain you. So these are the base cases are done, right? Now what's the next thing? Next thing is this. You have to convert this into a dp solution. Now this portion of the code, yeah, this portion of the code is executed when the value of this particular day becomes equal to 0, sorry, equal to 1 2 3 4 and so on till n minus 1. Whenever this becomes equal to this, you execute that, correct? And what can be the possible values of last? I again ask you the same question. And to that, you will be like, Striver, it will be like similar to 1 comma, it can be 0, it can be this, it can be this, it can be this. Again, makes sense. For 2, it can be 0, it can be 1, it can be 2, it can be 3. For 3, day 3, it can be last can be 0, last can be 1, last can be 2, last can be 3, right? So we can definitely follow this. So thereby we know for every day. So let's first write the code for day. So if I know that I'm gonna start, because what is tabulation? Previous classes, guys, what is tabulation? Tabulation is nothing but bottom up. So from 0 to the up, like if I show you the recursion tree, you'll start from here, then you'll compute this, then you'll compute this, then you'll compute this. Bottom up, recursion top down. This is what you require as the answer, but you go down, you go down, you go down, then you figure the answer. Top down. Okay. So what I know is, let's come back. What I know is I have I equal to, or I can say day equal to 1, and I'll go on till the day n minus 1. Now over here, can I say for every day, there are 4 different task values, 0 1 2 3 4. So I can say for every day there are 4 different task values from 0 to 3. Again, makes sense. Done. Once you have written the for loop, it's just copy pasting the recursion part. Once you have written the for loop, it's just copy pasting the recursion part. So whatever was written over here, yes, whatever you have written over here, just copy paste. I just copy paste that. So I can say now you have to perform task, correct? So if this is, or you can say this is last rather, instead of task, you can say this is last. So can I say over here, you'll just copy paste. What did you write? You wrote I equal to, or task equal to 0 to 2. And if, like, you just computed similar, just write the similar stuff. like it's getting a bit messy over here, but you can write the similar stuff like instead of f it will be dp of day minus 1, and I is basically this guy. That's what it will be. So what I'll do is I'll try to write this in code and then I'll come back again because it's absolutely getting messy over here. So in order to write the tabulation, what you will do is you'll declare a DP array of n cross 4 and super quickly write something like 0 on 0 with max of definitely points of 0 of 1 comma points of 0 comma 2. That's very obvious. And similar, I can just copy paste this thing for the other tasks, which is task 1. So if you're doing task 1, this will be 0 and 2, and if you're doing task 2, this will be definitely 0 and 1, correct? And for the last guy, it's very simple. It'll be 0 and 3, which means all the tasks. Just take all the tasks, simple as that. So max of points of 0 comma 1. That's what you can definitely do. So yeah, we've taken all the three guys. So that's the base case. Now what did I say? Where does the day start from? The day starts from 1 till n. So just go until n. How many last can you have per day? Number of last that you can have is definitely from 0 till 3. So you can just go on last plus plus. Now what did I say? Just copy paste whatever is written over here. Whatever is written over here, just try to copy paste this stuff. Okay, so let's copy paste this stuff in terms of task. You see me copy pasting. Okay, so I need the maximum. Now remember, what am I looking to compute? I'm looking to compute dp of last, correct? So really we can keep this as 0. So we're trying to compute it. Okay, and assume sorry, assume I'm taking a maxi variable, and at the end of the day, whenever I'll compute this, okay, at the end of the day, whenever I'll compute this, I'll store the maxi. How do you convert the recurrence? See, I'm gonna copy this exact same thing for int task. I'm not copy pasting because the indentation will go wrong. Task, there are 3 tasks, so I'll just go like this. What is written over here? If the task is not equal to last, right? I write the same thing. See, I'm writing the same thing. Task not equal to last. How many point does it gather? Point equal to points of day task. Same thing, see, same thing. Plus, now instead of f, now you're doing bottom up. This f would have been computed and stored in your dp. So dp of day minus 1, very good, comma task. So take this off. Okay, done. Next, you'll update maxi equal to max of maxi, comma point. So out of all points, whatever you got this, you'll just take it across. So instead of storing maximum, what you can do is you can directly store it in the dp. That's the better version. So you store it in the dp, and yeah, you can just keep it dp of day last. So instead of using a maxi variable, what I did was I just used this particular stuff. So I'll just omit this. And where is your answer? Was the initial call that you made to recursion? The initial call that you made to recursion was f of n minus 1, dp of n minus 1, and 3. So just make it. And now what I can do is you can definitely run this, and you see this running fine. Yeah, and you just submit it. Was tabulation tough? Was it tough if you would have written recursion? No, it was not. I told you in the starting of the DP playlist. Once I teach you DP, you'll never forget it. So that's how I wrote the wonderful recursion, and I just told you how to make sure the first couple of for loops are written. And once for loops are written, whatever is the recurrence, how do you just write them? And once you write them, you get your particular answer. That's how simple it is. Method takes a time complexity of big O of n cross 4 cross 3 because there are 3 loops, and the space complexity is still n cross 4. We have eliminated the recursion stack space. But how do you eliminate this? That's where something as space optimization comes in. Yes. So let's learn. Now, if I show you the code, how do you determine that there can be a space optimization? Whenever you see the dp of day last is actually using something like point, and if I just cover this off, like I can just write it over here, which is nothing but this. Like I just write it in one line, which is this. dp of day last is nothing but max of some dp of day last, comma something plus something, right? Now this something is a previous state of dp of day minus 1. Now remember, whenever you're computing dp of day last and you're taking day minus 1, so that's when you can space optimize. Whenever there is something like minus 1 minus 2, then we can think of space optimization. Let's see how. So specifically, how did this problem how was this problem solved? Like if there are multiple days, we created a dp array, right? Of, like, assume over here n is 5, and there were dp arrays something like this: task 1, task 0, task 2, task 3, and the days were like 0, 1, 2, 3, 4, 5. So initially what you did was initially you filled these guys. If I show you in the code, that's what you have done over here, right? This is what you have done. You have initially filled them, correct? Then you went on to fill this, fill this, fill this, fill this. Now, when you were trying to fill this, what was the line that you wrote? So let me just write it over here so that I don't have to again switch and switch. Last equal to something plus dp of day minus 1 comma task, right? That's what you wrote. So basically, if I carefully observe, what can be task? Task can be anything like this. So in order to compute this row, what did you require? You required this particular row's values, because day minus 1. Either this value, either this value, either this value, either this value. This is what you required. So assume you computed these guys, and then you move to the next day. What did you require? When you are trying to compute the row 2, you just require these values. There is no more requirement of these guys. It's not required. Using these values, you can actually compute these guys. And then again in the next, using these values, you can again compute these guys. Then again on the next, using these values, you can compute these guys. And again, when you go back, this guy is your answer. Correct? So, do we need to store an entire array? Can't we do something like this? Let's start off with a very small array. And what we do is we store this guy, this guy, this guy, this guy over here. And then create a dummy size 4 array and try to compute them. And then again store it. And then use this to compute the next. And then again store it. Then again use this to compute the next. Then again store it. And at the end compute the last. And thereby this will be the answer. Can I do this? Can I just store a size 4 array? If I just store a size 4 array, I don't require an n cross 4 array, because there's no need to store previous information, because what I require is just the previous guy. Thereby, I'll do a space optimization now. So I will be like, I don't need the entire thing. So what I'll do is, hey, why can't I just do this? I think I can definitely do this. I will be like, I'll declare a size 4 array, and I'll make the, see, I just made it. The first 4 is declared. So what I can say is this is declared. Declared. The first 4 is declared. Next, I'm at dp. So instead, now what I'm doing is I'm trying to compute the current day, which means I'm trying to create this. Which means I'm trying to create this. Trying to create this. So what I'll do is I'll simply keep something like this. Vector of int temporary of size 4 is what I'm looking to create. And what I'll do is, instead of dp, I'll just create temporary. Okay, so this is for the current one. So the current day will be stored in temporary. And this dp of day minus 1, now I know the previous is this current dp, like the previous guy. So what I can do is, or probably in order to name it better so that you understand, we can just make it previous. So the previous row is over here. So what I can do is previous, instead of day minus 1, I can directly take it because I'm concerned with 4 values. So I can directly take it. Once this temp is computed after this entire iteration, what I can do is I can say, okay, temp has been computed. Now let's make the DPS temp so that again on the next day when this guy has been computed, this can serve as for this guy and we can again compute this. So we keep on doing. And at the end of the day, instead of this, I can say the previous has my answer. This will be previous. The previous has my answer, right? And once the previous has your answer, you can definitely run it. Let's see if it runs. Yeah, it runs. And now let's try to submit it. It runs. And look at the time, 4:26 a.m. in the morning. And I hope I was able to make you understand. And the time complexity now boils down to n cross 4 cross 3. But what about the space? I'm just using a 4 size, which is as good as constant, I converted a 2D matrix to as good as constant, like 1D, like n cross 4 into 4, which is very, very good. So that's about the space optimization. I think I'm gone with voice because it was a very, very long video. So guys, I hope I was able to explain you the entire problem, all the 3 approaches. Just in case I was, please, please, please give me a like because it takes a hell lot of effort to make this content. And please do consider commenting US because that tells me that okay, the people who are watching the video are understanding it. This is please a mandatory stuff. Do it on every video if you are watching it. US or understood is what you need to comment. And also guys, if you're new to this channel, please do consider subscribing us because that numbers do motivate me to work more and more. And yeah, with this I'll be wrapping up this video. But yes, if you haven't checked out our SD sheet, the link is in the description. Make sure you check it out. With this, let's wrap up this and meet in the next video. Till then, bye bye. Take care.